and electromagnetic induction. Charge deflection by a magnetic field. So, if there is a magnetic field like north to south, remember the direction of the magnetic field is north to south, and second finger north to south, and second finger represent the direction of the movement of the positive charged particle. Say proton is a positive charge. So according to the Fleming left hand rule, if the positive charge moves through a magnetic field perpendicularly, then it experiences an upward force. So electric charges are deflected. Deflected means scattered by a magnetic field provided they are not traveling parallel to the field. তার মানেটা কি? তার মানে হচ্ছে একটা পজিটিভ চার্জ একটা ম্যাগনেটিক ফিল্ডের মধ্যে দিয়ে যখন ক্রস করবে perpendicularly or any other angle except parallel or anti-parallel, then these positive charge particle experiences a force, because we know when a charged particle move, then it produces a magnetic field. This produced magnetic field interact with the permanent magnet. That's why it experiences a force. Remember, positive and negative charges are deflected in the opposite direction. Look at this diagram. Here cross means the direction of the magnetic field is, the direction of the magnetic field is vertically inward. Cross means the direction of the magnetic field is vertically inward to the board surface, inward to the board surface. So according to the Fleming left hand rule, the first finger of my left hand represent the direction of the magnetic field. So here the direction of the magnetic field is vertically inward. So this second finger represent the direction of the current or positive charge particle movement. Then it shows this proton, that means positive charge, a proton experiences an upward force, but negative charge electron experiences a downwards force. So tell me, in which direction the proton will move? Tell me in the comment box, in which direction the proton, electron and neutron experience force. According to the Fleming left hand rule, my first finger represent the direction of the magnetic field north to south, and second finger represent the direction of the current flow. So this proton experiences an upward force, and electron experiences downwards force, and neutron does not experience any force because neutron is neutral. It has no charge. Okay. Now motor effect. Motor effect. So when a current carrying conductor carrying an electric current is placed in a magnetic field, it will experience a force provided that the conductor is not placed parallel or anti-parallel to the magnetic field line. So here magnetic field direction is north to south, and we place a current carrying wire between the magnetic field, then it experiences a force. This is called motor effect. This is called motor effect. This is called motor effect. So motor effect a wire carrying a current creates a magnetic field. These can interact with another magnetic field, causing the force that pushes the wire at right angles. So a wire carrying a current creates a magnetic field. These can interact with another magnetic field. So if a current carrying wire is placed between a magnetic field at right angle, then these interacts with another magnetic field, permanent magnetic field, causing the force that pushes the right angle. So look at this diagram. So here magnetic field is north to south. That means magnetic direction of the magnetic field is north to south. That means downwards, and current flows from positive to negative. Then it will experience a force right direction. That means the current carrying wire move or deflects to the right direction. So here you can use Fleming left hand rule to find out the direction of the force experiences by the current carrying wire. So here Fleming use Fleming left hand rule right in this way. Magnetic field is downwards and current flows from this direction, then it will experience a force. Okay. So how we can increase the strength or amount of force? By increasing the strength of the magnetic field. So the force increases if the strength of the magnetic field is increased, the current is increased, the amount of current is increased. So direction of the force is reversed if either the direction of the current or direction of the magnetic field is reversed. So we can change the direction of the force by reversing the direction of the current, by changing the polarity of the magnet. So if we want to change the direction of the force, we can do this by reversing the direction of the current by changing the polarity of the magnet. Now Fleming left-hand rule. Fleming left-hand rule. Fleming left-hand rule. So look, if the direction of my, this is my left hand, if the direction, if the first finger of my left hand, that means index finger, represent the direction of the magnetic field from north to south, and second finger represent the direction of the current positive to negative, then your thumb finger will show the direction of the force, direction of the force. So look at this diagram. The first finger represents the field. Field means magnetic field. Field means magnetic field, and from north to south. And second finger represents the direction of the current, positive to negative. Then your thumb finger. So then thumb finger of your left hand represents the direction of the magnetic, direction of the force. Direction of the force. So look, insert the missing information. Question number 1, magnetic field north to south is given. The direction of the magnetic field is given, and cross means the direction of the current is vertically inward. So look, here magnetic field is north to south. That means the front side of my index finger indicating south, and this second finger represents the direction of the current, vertically inward. Then thumb finger downwards. So the direction of the force is downwards. Now second one, direction of the magnetic field is given. And direction of the force downwards. So the direction of the current is vertically outward. So dot symbol, dot. Direction of the current is vertically outward from the board surface. Now third one, you have to find out the direction of the magnetic field, north and south. We have to indicate the north and south pole of the magnet. Here a force is given and direction of the current also given. Dot means the direction of the current is vertically outward, and force direction is upward. So north to south. This one is north and it will be south. North to south. Then here question number 4. Look at the question number 4. There is a rectangular coil. Coil is placed between a magnetic field. So north to south. Then this dot, that means the direction of the current is vertically outward. Then it experiences an upward force, and cross downwards. So it will rotate clockwise direction. Now motor, the electric motor. So an electric motor is used to convert electrical energy into mechanical energy. So different parts of the electric motor and their function. So a simple motor has the following parts: a power supply, mostly DC for the simple motor, field magnet, could be permanent magnet or an electromagnet, and armature or armature, commutator, split ring commutator, brushes, and axle. Working principle. So this is electric motor. When electric current flowing around the coil of the electric motor produces an oppositely directed forces on each side of the coil. This force causes the coil to rotate. Every half revolution, the split ring commutator causes the current in the coil to reverse, otherwise coil would stop to the vertical position. Look at this diagram. Here there is a magnet, rectangular coil. So brushes in contact with the split ring commutator. So current flows through the motor coil and forces exert a clockwise turning effect. So red one wire experiences an upward force, and black one rectangular arm of the rectangular coil experiences downwards force. So it rotates clockwise. So brushes in contact with the split ring commutator, current flows through the motor coil and forces exert on the clockwise. So when the rectangular coil goes vertical position, the brushes lose contact with the split ring commutator, current no longer flows through the motor coil. The coil will continue to rotate clockwise due to its moment of inertia. Due to moment of inertia, this coil rotates little bit. So brushes again contact with the split ring commutator, current flows through the motor coil but in opposite direction. Forces exert a clockwise turning effect on the coil. In this way, so uses of electric motor. Electric motor are used in variety of applications. Some of them are listed below: drill machine, water pump, hard disk drive, washing machine, industrial equipment. So remember, when a current passes through the coil, the current creates a magnetic field around the coil which interacts with the field of the magnets, exerting a force on the coil. In accordance with the left hand rule, this pushes one side of the coil up and other side down, causing it to spin. So what is the role of the split ring in the electric motor? So remember, split ring is used to reverse the coil's current direction. The coil's current must be reversed for it to continue rotating in the same direction. As a result, the direction of the couple rotating, the coil remains in the same after half rotation, and the coil continue to rotate in the same direction. Now loudspeaker. Now we discuss about loudspeaker. So loudspeaker. Alternating current supply to the loudspeaker creates a sound wave in the flowing way. So a current in the coil creates a magnetic field. The magnetic field interacts with the permanent magnet, generating a force which pushes the paper cone or diaphragm outward and inward. That means back and forth movement, which pushes cone outward direction, and there produces a sound. So there is a permanent magnet here, permanent magnet, and there is a movable coil. This a paper cone is attached with the paper cone. When an alternating signal passes through the coil, then there produces a changing magnetic field which interacts with the permanent magnet, and there produces a force. Okay. So sound signal consists of an alternating current supplied by the amplifier. So this current flows through the coil of loudspeaker. So due to the motor effect, the magnetic field around the coil causes the coil to vibrate in step with the alternating current. So the coil causes the diaphragm or speaker cone to vibrate in step with the original sound. So the diaphragm causes ear to vibrate and so produces a sound wave. So actually there is a E-shaped permanent magnet. A movable coil is placed between the permanent magnet, and a diaphragm, paper diaphragm or paper cone is attached with the movable coil. When varying alternating current from the amplifier enters or passes through the coil, movable coil, then there produces a changing magnetic field, because we give input of varying alternating current from the amplifier. So there produces a changing magnetic field. This changing magnetic field interact with the permanent magnet. There produces a back and forth vibration, back and forth and to or fro vibration of the movable coil, and there is a diaphragm, thin diaphragm attached with the movable coil. Then diaphragm vibrates with the original sound. Then the coil causes the diaphragm speaker cone to vibrate in step with the original sound, original sound signal. The diaphragm causes ear to vibrate and so produces a sound wave. So remember, loudspeaker is the application of motor effect, one of the important application of the motor effect. So there is a mini version of speaker. Look, there is a coil, movable coil which is placed between a magnetic field, and when changing varying current, alternating current passes through the coil, then there produces a changing magnetic field. This changing magnetic field interacts with the permanent magnet, and the changing magnetic field interacts with the permanent magnet, and there produces a vibration or to and forth, back and forth or to and fro vibration, and paper cone is attached with the movable coil, and there produces a vibration, also a vibration. Look, this coil vibrate to and back and forth because there is a permanent magnet, red color permanent magnet. Look, this one is a permanent magnet, and this movable coil is placed between a magnetic field. This one is a coil, black, and we apply varying current. Varying current means alternating signal or changing magnetic field. Try to solve this one. Motor effect occurs when The motor effect occurs when dash a carrying a wire, a current carrying wire is placed inside a magnetic field. Inside a magnetic field, force is exerted. Force is maximum when the wire is at right angle 90° to the magnetic field direction, but is the zero if the wire is parallel or anti-parallel. So the force increases when the field or current strength. The force reverse is direction of if either a reverse. Applications is include the electric motor and loudspeaker. Now electromagnetic induction, this is the interesting part. Look, if there is a magnetic field and this one is a closed loop wire and this wire is attached with an ammeter. Ammeter indicates the presence of current in the closed loop circuit. If an electrical conductor cuts through the magnetic field line, a voltage is induced. Or EMF is induced across the ends of the conductor. If the wire is the part of the complete circuit, a current is induced in the wire. This is called electromagnetic induction and sometimes called generator effect. Sometimes we call it generator effect. So remember, current only produced when the wire cut this magnetic field. So look, if the magnet is moved, the north pole of the magnet is moved into a coil of wire, a voltage induced across the ends of the coil. If the direction of the motion or polarity of the magnet is reversed, then the direction of the induced voltage and the induced current also reversed. Electromagnetic induction also occurs if the magnetic field is stationary and the coil is moved. The size of the induced voltage or induced EMF increases when the speed of movement increases, the strength of the magnetic field increases, the number of turns on the coil increases, the area of the coil is greater. Area of the coil is greater. Okay, now alternating current generator. This one is the diagram for alternating current generator. Remember, this alternating current generator has two full ring. Now bicycle generator. In a bicycle generator, there is a rotating magnet which attached with the axle, and first end of the axle there is a rotatable wheel which is attached with the bicycle wheel. When the wheel turns, wheel turns, the magnet is made to rotate next to the fixed coil of wire. Electromagnetic induction occurs and alternating voltage is induced in the coil. This causes an alternating current to flow to the light bulb of the bicycle. So when the wheel of the bicycle rotates, then the wheel turns, wheel of the bicycle generator also turns, and magnet rotate rotate next to the fixed coil of wire, electromagnetic induction occurs because the line of force of the magnet cut by the coil of wire, then there produces an induced EMF, and a voltage is induced in the coil. This causes an alternating current to flow to the right light bulbs of the bicycle. Thank you for watching my video. If you think this video is useful for your study, then subscribe my channel, press the bell button and share my video with your friend. Thank you very much. Stay with me.